the archives. Yeah.
Okay, hello. So, supercomputers, eh? All right, so we were focusing for last few months on supporting better support for GPUs in EASY. And we call this talk from 0 to science in seconds, because we were able to run EASY with GPU-enabled software just in a second. So maybe brief introduction about INUITS. It's a Belgian company. We have also some branches in other countries. So I'm from Czech Republic. We have also a branch in Ukraine. And we like to do a lot with open source. So that's why I'm especially keen to be able to contribute to EASY and EasyBuild. So more about me and Anthony, so you know a bit of the background. So I like tinkering with computers from very young age, and I was able because of my father. I love Python. That's connection with EASY. And back in the day, I also contributed a bit to the EasyBuild configurations, configs, and now also in EASY. So maybe also introduction for Anthony.
I'm Anthony. I joined INUITS in September this past year. I work a lot with AI. My thesis I'm currently working still on is also about AI. I like to cook and I like to eat. And I'm now the past month and a half I've been working on EASY.
So as I mentioned, I worked for EasyBuild and around year 2019, 2012, 2020, sorry. The last year, I have a colleague of mine here, Pavel. Where is he? There. So he also is one of the top contributors for EASY configs for the last year. And also we were able to get to do work on EASY this year, so which is why we're here. So maybe you know the metrics from a disk, mean time to failure. So that was inspired by calling it mean time to science. So actually how fast you can start doing your calculations. What's the issue with the GPUs built on top of EASY is that actually you have all the processors or all the different AMD and other stuff. You have the software and the GPUs add the third dimension to the table because you need the combination of CPU and GPU or CUDA capability. So currently, I think Lara mentioned that this morning there are Zen 2 and Zen 3 builds for CUDA 8. So I'll mention at why this is important. Can you see the small font? Hopefully, yes. So the issue is that you need to have CUDA on your machine. And due to licensing of the NVIDIA, EASY is not able to distribute all of the libraries you need. So first, need to check if the CUDA module is available because all of the packages that are depending are built over the CUDA via EasyBuild. So if it's available on EASY in CVMFS, you can just go through next step. If you don't have the CUDA module, you need to build it. And it takes time. Then, if you have software present on the EASY, in the CVMFS, you can start running the application right away, even with GPU enabled, because we're able to distribute the runtime libraries, but not the build time libraries. But if you need to build the software on site, you need again to install the CUDA. So we have three scenarios. The first one is the fastest one. So if the CUDA module and the GPU enabled module is already built in EASY with correct processor architecture and with correct CUDA capabilities, you can spin it up in 20 seconds. Hopefully we will show the live demo at the end. If you don't, you need to download CUDA, install CUDA locally, build the module if it's not there, and then you can run it. The difference between the second and third scenario is there because about a month ago, the CUDA and CUDA samples modules were removed from the generic repositories for generic processors. So we had to build the modules ourselves. So the only difference here, so here is the CVMFS. Here is the host injections. So in the second case, there is no CUDA module because it was already defined in the CVMFS. And you have the locally built module you needed. The only difference is, the only difference is that you need to build the CUDA module yourself if it's not already present in the CVMFS. So we need a bit more hack in the script. I'll mention that later. So there, Lara mentioned several helper scripts, which helps you to set up the dependencies which are needed. There are two different scripts. So first is link the NVIDIA host libraries on the bottom. And it will just helps you to link all the drivers and libraries from NVIDIA to host injections. It does nothing else. So it finds like the libcuda, so, and other stuff. And the two up scripts, the install CUDA and libraries and install CUDA and host injections, they're doing basically the same thing. One is older, one is newer, and probably the install CUDA and libraries will be used in the future. But since it's a bit faster to run the second install CUDA host injection script, we are using it in this demo, so just you won't get confused. So how do we start? This is about provisioning the VM, so it has nothing to do with EASY, but you need this time to set up the machine. So you click some create machine or whatever. It will take time to boot an image. Then you need to SSH into the VM. Install NVIDIA drivers because it's not covered by EASY. It's different drivers for different stacks. And after that, you're ready to install EASY, right? So far, so good? All right. Leverage the VM snapshot. So if you do all these steps, you can do a snapshot and have it ready for the next run. We produced two scripts. They're in a demo, easy demo repository online. One is install.sh, and it's just a wrapper you can use on virtual machines that it will install easy. And I'll go briefly through the process. So first, we check that we have NVIDIA somehow present, because it makes no sense to continue further if there is no NVIDIA. Then we will have install easy and source easy. It's the same like Lara showcased, nothing special. And then there's the link CUDA libraries script, which we are using. That's easy. And then we need to check if we have the CUDA available. So that's the three different options. If it is available, we're just loading CUDA samples in the install.sh. So we actually run some GPU-enabled software, and we are proving that we can run it. And the specific binary is device query, which basically lists all the GPUs that are available. And we're ready to run easy. If not, CUDA wasn't found, we need to install the CUDA into host injections. And that's because we need a CUDA module to build further. So then we have the run demo sh, which basically runs the demo. So again, source easy. Then we're loading also easy extend because sometimes we need to build the libraries locally. So thank you to Pedro, which showcased the easy extend. And then we check if the module is available in the CVMFS. If it is, great, we can run it. So hopefully that's the case we'll be showcasing. If the module is not found, you need to build it from scratch. And because we're not able to, provide the build libraries via easy, we need to install CUDA locally. And it takes time and space. So just a brief mentions, you need some space to install CUDA. So in VMs, it could be an issue. So keep in mind that you'll need some space to download the CUDA installer, run it, store it somehow. And also, just to prove that we're able to run the GPU-enabled software. And now I'll pass the word to Antoni. He will talk more about the Azure VMs.
Yeah. So this is our measurements from executing GROMAX on the CPU, on the VM, on Azure, and on the GPU. And as you can see, the measurements are not correct. We'll skip that for now. Okay, so we focused on Azure, but all you really need is a VM with the NVIDIA GPU. On Azure, these are the families of VMs that have NVIDIA GPUs. So the second column is the CPU architecture for each family, and then we have the CUDA compute capabilities for each GPU. The CUDA compute is important because this is when you compile your GPU software, that is the CPU architecture that you're compiling it for. So we need to keep that in mind. And if you want pre-compiled software, then you will need one for each architectures. If you go outside Azure, you will need even more. So on Azure, if you create a VM on Azure, also remember to install your drivers and stuff like that. Then costs. Azure GPUs can be expensive, but not if you're just running short computations. For example, in our case, over the course of 3 weeks, we spent €40. For a couple of hours, it's a couple of dollars. Depends very much on how heavy you scale it. These are the smallest sizes of each of the types, but it can be cheap. Also, if you use spot instances, it can be even a lot cheaper. But then, of course, you need to keep in mind that your VM can be interrupted from time to time. So this is a output from our runs on a GPU, on a VM with the A100 GPU. This is a setup where we have already pre-compiled packages available on Easy. So here our time to execute everything is less than half a minute, and you're running code on the GPU. On Azure you can run GPU code, your science in less than half a minute once you have your VM, of course. We have a little demo if we still have time. Okay.
I just want to say that also we were able to publish a blog post. It's the journey about our R&D with the GPU. If you want to know more specific information about that, please check the blog post. It's very detailed, and it has a bit more information that's in the presentation. So we were able to get our hands on a 100 VM in Azure. So hopefully we will showcase the 30 seconds transcript.
Right. So this is our VM. You can see it from NVIDIA SMI that we have our so we have our VM, but it's not responding, of course. Now it is. Okay, so we have our code. This is the demo code. It's old one, but we added ours. So if you go into the GPU directory, that our stuff is, then we can install. Now this takes about 30 seconds normally. So it installs CERN VMFS, then it pulls the easy software layer. It will link the NVIDIA libraries. Then it will install CUDA, and then, or if it's already installed, if it's already precompiled, then it will skip that step. and then it will run device query, which is a CUDA sample, yeah, like an example library, and if that works, okay. Okay, so device query worked. So we have running, yeah. So we have CUDA compiled and ready. Now we need to
So we included for comparison the CPU and GPU versions in the demo, and we actually ran each demo 3 times because we are also curious about the times of loading the modules. So that's why you see in the demo both CPU and GPU and run 3 times. But since we need to showcase the demo, I'll be running it just single time for the GPU.
now it will, if the modules weren't there, it would compile them, but they will be there, so it will just run it. Now it's running the Espresso on the GPU. Also loading the files from CERN VM edit. That's why it's taking a bit. Running. Yeah, that's easy on Azure in the cloud in less than a minute.
Thank you very much.
Right, thanks a lot. We have time for maybe one question. There's one online. Okay, here we go.
How easy is it to do that with Azure Cycle Cloud DevOps pipelines?
About what?
Cycle Cloud DevOps pipelines. I know, so I've heard of Cycle Cloud DevOps pipelines in Cycle Cloud. I don't know.
I don't know the details about it either, but it's really as simple as installing packages and creating configuration files. So as long, for the native installation at least from CVNFS, as long as you have sudo permissions, you can do the exact same thing in let's say half a minute. So
Yeah, maybe even the same script, right, potentially, right?
yeah.
Or at least we could get to that point, right, where that's what it would be like.
Okay. No, this is, so they did a whole bunch of stuff. The blog post is on the Easy blog actually, that has all the details. Okay, it's, yeah, the link is in Slack as well. They also improved some of the scripting we had already done for the NVIDIA GPU driver detection, and all of that now has proper debug mode. It has nice error messages. It even has CI workflows in GitHub as well, so it's going to be a lot more difficult for us to break it if we make any more changes going forward. So this was all very valuable work. Yeah. Okay, no more questions. So yeah, thanks a lot both.